So first you learned how to think critically, and then you learned how to think outside of the box. But the whole point of all of this, we're trying to get momentum to write a proof. That's like our final product. That's what we wanted to be able to do, is to be given a certain situation and to prove that it's true for every case. And I'll tell you, it's weird, but it's like very rewarding when you get it, because it's like it takes a lot of brain power to get there. So it's like kind of exciting because like you guys have been growing and learning, and then you're gonna put it all together. So before we can write like a segment proof or an angle proof, we have to kind of talk about how you write a proof. So we got to talk about a few things first. A postulate or axiom, a theorem, those are just statements that are accepted as true without proof. Like they are true no matter what, because someone a long, long time ago said that they would always be true. Okay? So, does anyone remember what our three undefined terms are in geometry? What are our three undefined points, lines, and planes? Now we have 7 things that we know are true involving those things, okay? So this is where there's kind of a lot of talking and you just write a lot. The first one says through any 2 points, there's exactly 1 line. That's our first postulate. And now we have a nice picture to go with that. So line N is the only line through points P and R. You can't draw multiple lines through those 2 points. There's only one that exists. That's your first postulate. Our second one says through any 3 non-collinear points, we have 1 plane. So in that diagram there, plane K is the only plane through those points A, B, and C. Now the next postulate is kind of like the opposite of the first one. It says a line contains at least 2 points. So line N contains points P, Q, and R. There has to be at least 2, otherwise it would just be a point. So for there to be a line, you have to have at least 2 points. Okay, our fourth one. A plane contains at least 3 non-collinear points. So plane K contains non-collinear points B, C, E, and L. Our fifth one. If 2 points lie in a plane, then the entire line containing those points is also in that plane. And that should make sense, right? A line goes on for forever and ever and ever, right? And so does a plane. So if a line is on a plane, then all those points are also on the plane. So points A and B lie in plane K, and line N contains points A and B, so line M is in plane K. Now the last 2 are a lot more easy to visualize and think about. 2 lines intersect in what? A point? Just 1 point. So in that picture there, S and T intersect at point P. And we know that 2 planes intersect in 1 line. So planes F and G intersect in line W. So I understand we just wrote down a lot of information. I didn't give you a ton of time to think about it, but we'll use them enough today where you'll get pretty familiar. Do you guys see these numbers on them? Instead of having to write out what the postulate is, just refer to it as like number 6, number 1. Otherwise you'd be writing all day long today, okay? Does that make sense? Okay, so now we're going to be given a picture, and we got to figure out which one of these 7 describes that picture, okay? That's what our job is on the next page. So on the next page, we have a picture of what? A skyline? So we have to describe what's happening in the picture and then what postulate makes it true. So on this first one, it says lines N and P intersect at point D.
6.
So before we get to the postulate, we gotta describe what it's describing on here. So what do lines N and P represent on our picture? Your line is N and here's P. What does that represent on our building?
Vertex.
Well, they're not planes. Like, can we just say like the edge of the building, right? The top edge. So let's say the lines represent the top edge. The top edge of the building. Yep, describe what it's describing or list what it's describing. Now you're gonna have to refer back to that other page. What postulate talks about two lines intersecting at a point?
6.
So you're just gonna write number 6. If you want to be really fancy, you could write the whole thing out, but I think just writing number 6 is a lot more efficient than having to write out the whole postulate. Okay, our next one. Points A, B, and D form a plane. Well, what do A, B, and D represent on our building?
The side of the building.
Well, points can't represent a whole side. Could be corners. Someone said they could be like, what if they're like windows? Could they be like windows on your building? Random spots?
No.
You guys don't like that?
No.
Okay. So then should we just generalize and say random spots on the side of the building?
Yeah.
Okay. Points represent random locations. Okay, so now what postulate talks about 3 non-collinear points making a plane?
Number 2.
So you're gonna put number 2.
You said number 5.
Alright, next one. Points A, B, and C are points that make up line J. What do those points represent?
The corner of the building.
Sure. Points make up corners of the building?
Wait, point B does not make up a corner.
Okay, we can't use corner. What do the points represent?
Sides.
Random locations on the side of the building?
But we already did that.
Well, because there's still points, so it can't be a whole side. So maybe we should just say location again. On edge of building. Okay, what postulate talks about multiple points making up a line? I think it's number 3. What does number 3 say? It contains at least 2 points a line?
Yep.
So yeah, number 3. Number 3. Okay, last one. The plane that contains points A, D, and E intersect the plane that contains points F, G, and D in line A. So just maybe focus on the plane, right? What does the plane represent in this picture? So the planes represent the side of the building.
Oh, they both repeat inside the building.
Yeah.
Wow.
A lot of changes.
And then what postulate talks about planes intersecting in a line? What number is the last one? 7. Number 7. Is that okay? Okay. On the next set of examples, folks, it's just a general situation. We don't have a picture, okay?
What's the number?
So determine if the statement is always, sometimes, or never true, and explain with one of our postulates, okay? The first one is kind of tough to start off with, but we're just going to do it anyway. So it says if two coplanar lines intersect, then the point of their intersection lies in the same plane as the two lines.
What?
What? Let's draw a picture. Draw a picture with me. Start with a plane. Plane.
Didn't we do this last year?
Draw a plane.
Box.
What does coplanar mean? So two lines that intersect in our plane. Draw that.
That can be sometimes true.
So if our two lines are coplanar, then that point of intersection is also on the plane. Is that true? Or sometimes true, always true, never true?
Always true.
That one's always true.
Come on, baby.
It's always true. What postulate describes that, you guys?
Number
Look on the other page. Which one describes it?
number
I don't think it's 6.
no, it's not 6. It's
Number 5. Number 5. That's what number 5 is describing, you guys. Okay, 4 points are non-collinear. Why is it sometimes?
It can be.
Or they don't have to be. So you can just draw a picture. That's when they're all on the same. Or if they're not. So sometimes, good work.
Number 3.
So the picture is enough to justify it, or which postulate kind of describes this one? Number 3. Yep. Okay, 2 intersecting lines determine a plane. Let's draw a picture. How many points to make a line? 2. So why don't we start there? I'm gonna scroll. Okay, that's one line, my purple line. And I know they're intersecting. We'll call that one, let's say E. So now, no matter which 3 points I pick, are they always non-collinear?
No.
Yep.
I don't know.
Okay, knowing that one has to be
E.
Yeah, one has to be E.
Then they're all what? Then they're all co-plane.
So if you pick 3 points in this picture, would it always make a plane?
No.
Why?
Because one could be off the plane.
A,
Like this.
straight
A
line.
one could be off the plane.
Would not work.
So if let's say we pick points A, E, and D, would that make a plane?
Yeah.
Because they're non-collinear. What if I pick points C, E, and D?
Wow.
Because they're collinear. But
Sometimes.
so sometimes.
Oh my goodness.
This one is like.
This is like
It's number 6.
That one's number 6. That was a tough one. This one's easier. Do 3 lines intersect in 2 points? What are the lines intersected? 1 point, so that's never. Which one talks about lines intersecting in 1 point?
6.
Oh, this one should be number 7, you guys.
Oh,
No, which one talks about a plane being made? 3 non-collinears. No, not 14. 3 non-collinear points make a plane?
Oh, that was 2.
2. This one should be number 2. You guys, I'm very excited for this next part. Oh, you should be. We're finally going to write our first proof. Okay? So just know, you guys, in a proof, you can't do anything. So I think after today, we will go back to our seating chart during notes because we can't handle it. This was never an issue before, and it's okay, right? You want to talk to your friends when you're by them. But for the material that we are doing, we cannot be distracted, and I don't want people who are trying to learn distracted. So moving forward, when you guys come to class tomorrow, be in your assigned seats, and then during work time, you can move. All right? All right, so with the proof, you guys, you can't do anything without saying a reason for it, okay? Otherwise, it's just not right. So the first kind of proof we're going to do is a flow proof. The way you start is always with your given, so our problem. So that's what you're going to start with first. So you guys just kind of follow me. It's going to feel weird at first until you get the flow of it. No pun intended. So start with your problem. Put it in a box, and your reason is given. Your given is what you're starting with. That's how you start every proof. So on a quiz or test, if you have no idea how to prove it, that's worth 1 point. So at least you'll know how to do that. And now we're starting with an algebraic proof because you guys know how to solve an equation. What would you do next to solve? Pretend you don't know this. That's what we're trying to prove. Pretend you don't know that. Multiply by 3, right? So you're going to draw an arrow. Put your next box. Now if we multiply by 3, we're going to have y plus 2 is equal to what? 9. Now what did we do there? What did we just do? Multiplication. So that's what you're going to write. Multiplication property. Bless you. That's our reason for what we did. Multiplication property. Mode your last steppy. How did we move to?
Subtract.
So that's our reason, the subtraction property. Running out of space. That's a subtraction. So did we just prove that y equals 7?
Yes.
Okay, that was pretty exciting.
Let's go.
You loved it. You loved it. Okay. Now we're going to do one with a little geometry. Okay, same idea, but we're just making it geometric. Okay. So it says, given that P is the midpoint of segment JK Write a flow proof to show that x equals 2.
Yeah.
If p is the midpoint, what's something you automatically know?
X equals
JP
5
equals
X
PK.
minus 6.
Yeah, I would write that right here. You guys, we know that. Or you can do your little tick marks. You know that's true since p is the midpoint. That's kind of like your brainstorm over there. Okay, how did we start the last problem? What do you always start with?
The given.
You're given. So in your first box, you're going to write P is the midpoint of JK. That's your given. P is the midpoint of JK. That's in your first box. Given. Now, what did we know was true because P was the midpoint? Yep. But technically, we should say segment JP is congruent to segment PK. That's what should come first. And now what's kind of nice about proofs, you guys, the property is kind of in the description. That's just definition of a midpoint. Definition of midpoint. That's your reason. So now we're going to kind of encounter like a technicality that really only shows up in our class. Before I can like plug in my values, I have to get rid of that segment bar and the congruent symbol. So now I'm going to say JP is equal to PK. I know it seems like it's the same thing, but they are different. And that property is the definition of congruence. And what's not fair is we don't formally talk about that till the next section, but it comes up in this one. Yeah. Because it's either going to be a property or a definition. Otherwise, you can't use it as a reason. Right. So you can't just say because I want to. That's not a good enough reason. It has to be like a property definition. It has to be like a logistical thing that already exists. Okay. What does JP equal?
Okay.
Yep, but on our picture it equals
X.
X, right? What does PK equal?
5x minus 8.
You guys know what we call that step?
No.
No, not multiplication. When you plug something in for something else, what is that called? Like when you're in a basketball game, the coach puts someone in for you.
Substitution.
Substitution property. I'm running out of room, so I'm just going to go this way. Now what would we do? If you're solving for X. Subtract what?
No, add 8.
No, you add 8 minus x.
I would probably minus 5x over here. So what are we left with? Equals negative 8. Subtraction property. And then what's our last step? Divide, yep. So x equals. Is that what we wanted?
Yes.
Good job. We're going to save the last proof for a different time. Just so you guys get some work time.